Alright, Mr. T here. We're going to be analyzing functions with successive differences and ratios. Alright, so this is what we did today in class. The first part, we want to graph the ordered pairs, the set of ordered pairs, and tell whether it's either going to be a linear function, a quadratic function, or an exponential function. Alright, so let's look at number 1. We have the point 2, 3, so over 2, up 3. Alright, we have the point 1, 1, 0, negative 1, negative 1, negative 3, and negative 3, negative 5. Alright, and if I draw a line through, alright, that's clearly going to be a linear function. Alright, linear function. Just because it's a straight line. Alright, I'll show you one more, just so we have another example, because linear function is definitely the easiest of the three. So let's go over to number 2. Negative 1.5. Alright, so about right here. 0, 1, 1, 2, 2, 4. Okay, so here we're going to have a smooth curve. Alright, and this is going to be an exponential function. Alright, it's exactly what we want. Alright, and then when we go down here, we want to look for a pattern in the table of values to determine which model best describes the data. Then we want to write an equation for the function that models that data. Alright, so I'm going to look at number 5. We have a table. Our x values range from negative 3 to positive 2. And then our y's, we have 32, 16, 8, 4, 2, 1. Alright, so the first thing we want to look at is if it has a common difference. Alright, so I notice this is minus 16, alright, minus 8, minus 4, minus 2, minus 1. Alright, so there's clearly no common difference there, so it's not going to be a linear function. Let's check again, though, to see if it's going to be quadratic. Right here we have plus 8, plus 4, plus 2, plus 1. Alright, so there's still no common difference, so we know this is going to be an exponential function. So it's going to be written in the form y equals ab raised to the x, where b is going to be the common ratio. Alright, and you find the common ratio by looking at the y values. How do you go from 32 to 16, 16 to 8, 8 to 4, 4 to 2, 2 to 1? Alright, you're multiplying by 1/2. So my common ratio is going to be 1/2. So I can rewrite this as y equals a times 1/2 raised to the x. Alright, and now I'm able to find my a value by plugging in a point. Alright, so let's take the point 1, 2. 1, 2. So I plug in 2 for y equals a times 1/2 raised to the 1. Alright, and anything raised to the power of 1 is just the same number. So this is a times 1/2 equals 2. And to solve for a, we're just going to multiply both sides by 2. You get a equals 4. A equals 4. Alright, so now I know the equation of my exponential function is y equals 4 times 1/2 raised to the x. And if you take any of the values from your table, you should be able to plug it in and get the output you're looking for. Alright, if you want to, we can just, we'll take this point 0, 4, we'll plug it in and see if it works. So when I plug in 0 for x, do I get my output as 4? So I have 1/2 raised to the 0 power. Anything raised to the 0 power is just 1. So 4 times 1 is 4, which is my y. So that checks out. Alright. If you haven't done so already, please subscribe. It's Mr. T, Good Stuff Math.